Dear students, Assalamu alaikum and welcome to the 13th program on Software Engineering 1 course. In the last few programs, we discussed the system analysis phase, which is one of the most important activity in software engineering process. During analysis phase, a software engineer gets the understanding of the system to be built. He gathers the system requirements using various requirements elicitation and analysis techniques. He prepares a number of different system models which help him to understand the system and its requirements better. The models that are prepared can also be thought as a formal documentation of the system. Dear students, once the analysis is complete, the system design activity can now begin. In this program and in the couple of next programs, we will be discussing the software design activities in detail. We'll describe the process of software design where informal ideas are transformed to detailed implementation description of the system. We will also introduce the basic design principles and their importance in software design. We will discuss how various designs can be obtained from different analysis models we prepare during the analysis phase. In today's program, we'll define software design. We'll discuss how various design models can be obtained from the analysis models. We will outline the design process and we will discuss the characteristics of a good design. So let's start by defining what do we mean by design. The design is the process of applying various techniques and principles for the purpose of defining a device, a process of a system in sufficient detail to permit its physical realization. Of course, in our case, the device is the software. So basically, design is concerned with giving the details of the system in such a depth that the system can be built. So the basic design models which are prepared during the software design phase are the data design, the architectural design, the interface design, and the procedural design. Now note one important thing here, that all these designs are inferred from the analysis models. For example, the interface model and the interface design is derived from the data flow diagrams, and the procedural design is derived from the state transition diagrams, control specification, and the process specification. So the main idea here is that all our software design must be derived from the analysis models. So analysis model is the basis on which the design is built. Now, during the data design, the data design transforms the information domain model into data structures that will be required to implement the software. Of course, data dictionary and the ER diagrams are the basis for data design. Now, if you are working on a pure database application, then that design might involve only transforming the ER diagrams into the relational tables, for example. If you are working on a different kind of software, the data design might involve not only defining the tables which can be implemented in some kind of software, but also defining the data structures which should be used to implement the software. The architectural design defines the relationships among major structure elements of the problem. Generally, subsystems are identified and a framework for the subsystem control and communication is established during that design. The interface design, which is derived from the data flow diagram, describes how the software communicates within itself to the system that interoperates with it and with the user. An interface employs flows of information, that's the data and control. Therefore, data and control flow diagrams provide the information required for the interface design. The procedural design, which we are driving from the state transition diagram, the control specification, data flow diagrams, and the process specification, transforms the structure element of the program architecture into a procedural description of software components. Information obtained from piece specification, the process specification, and the control specification, state transition diagram, and the data flow diagram basically serve as the basis for procedural design. Dear students, to do a good design, a software engineer must understand the problem first. He should look at the problem from different angles to discover the design requirements. He also needs to identify one or more solutions to the problem. He should evaluate each one of them and choose the most appropriate solution. Once a suitable solution is identified, it should be described using some graphical, formal, or other descriptive notations. Design process is a highly iterative in nature. In the design process, generally we start with informal design outline. We refine it to make it a little more formal design. We keep refining the design until we get a satisfactory design of the software. And these arrows clearly show that the design process is not a linear in nature. While you are doing the informal design, you might have to go back and do the informal design outline again. So the design is gradually done. So the process by which a design model is developed combines intuitions and judgment based on experience. In building similar entities, a set of principles and or the heuristics that guide the way in which the model evolves. A set of criteria that enables quality to be judged, and a process of iteration that ultimately leads to a final design representation. Therefore, design is not done by purely some mathematical means. Design is a creative activity. A good design not only depends on knowing the basics of the software engineering and the system analysis and design, but it also depends on the experience of the designer of developing similar systems. It also depends on his judgment that how good a design is. It depends how good a person can judge the things. As we said before, the software engineer should look for a variety of designs and should select the best out of them. The question is, how can one judge which design is better? Of course, again, there is no magic mathematical formula which can be used to ascertain this or that design is the best one. Question is again, then how can we judge that this design is a better design and it should be selected? Of course, there are certain characteristics which a good design should exhibit, and a designer should be looking for them in the design. If a design exhibits or has those characteristics, then we can assume the design is a good design. For example, a good design has: the design must implement all the explicit requirements contained in the analysis model. It must accommodate all the implicit requirements. Now, about the implicit and the explicit requirements, which is very crucial in software engineering. The implicit requirements are not generally given to the software engineer by the user. The user expects that the designer is already aware of those requirements, that every good software should have those things. Therefore, user doesn't bother to mention them explicitly. For example, every good software should be easy to use, should be easy to install, should have a good user interface. So some of the requirements which are implicit and not directly identified by the user are not generally given. But a good designer must accommodate not only the requirements which have been well documented during the analysis phase, but he should also take care of the implicit requirements in the design. The design must be readable and understandable. Of course, once the design is ready, it has to be developed by the developers. On the big software projects, the analysis might be carried out by one person or a team of people, and the design is done might be by a different team of people. And the development might be done by totally a different team of programmers. Therefore, the design which is created by the designer or the software engineer must be readable to those people who will be actually implementing the design, and it should be understandable. Of course, the design must be documented in a language which is very clear. If required, the standard notation should be used. That could make the design understandable by the programmers or the people who will be actually implementing the design. The design should address data, functional, and behavioral domains from the implementation perspective. Dear students, design is the basis on which the development is done. Therefore, when the software engineer is doing the design, he must take care of all the three important parts of the software: the data, the function, and behavior of the software. And each one of them must be properly documented in detail so that it can be properly implemented. And a design should exhibit a hierarchical organization that makes intelligent use of the control among elements of the software. That point will become much more clear as we go along with the design activities, and we'll explain at that proper time what do we really mean by hierarchical organization of the software. Another important characteristic of a good design is a design should contain both data and procedural abstraction. Another characteristic of a good design is a good design should lead to modules that exhibit independent functional characteristics. We'll be discussing these 2 points in much more detail, that what do we really mean by data and procedural abstraction and the independence of the functional unit of the software. Also, a good design should lead to the interfaces that reduce complexity of connection between modules and with external environment. We discussed that point many times in our previous programs, that a big software is basically developed in modules, or a system is made up of subsystems. These subsystems have to interact with each other. If you are just talking about the software, then your software might be composed of a collection of modules or functions or procedures. These functions and procedures must work together. They make the calls to each other, and each function or the procedure accomplishes ideally a single task. So these modules do interact with each other. Now, you can make two modules to interact with each other by defining the interfaces. Talking in terms of C language, you can think of interface as defining a function prototype. So you should be defining the function prototypes which are very easy to use. You should not be passing too much of data to each function, for example, or the name of the prototypes should be self-explanatory. We'll be discussing that point in much more detail, that how can you make the interfaces easy to use and how we can make the different components of software to interact with each other easily in the coming programs. Another characteristic of a good design is a design should be derived using repeatable methods. Now that's again a very important point. Design should not be based on the capabilities, abilities, and imagination of the individuals. A good design should be obtained by applying the methods and the principles which are repeatable. That means if you apply the same principles and the same methods, you will be getting the same design again. So the quality of the design should not depend on the quality of the individuals who produce that design. Rather, the quality of the design should be based on the quality of the procedures which are used to create that design. We discussed what are the characteristics of a good design. Now the question is, how can we achieve those characteristics in a design? As I said before, there is no mathematical magic formulas which can be used to have a good design. There are, of course, a number of design principles, if properly used, can lead to a good design. Let's have a brief look on those principles. The design process should not suffer from what we call the tunnel vision, which simply means that a designer must explore all possible alternative design and then select the best one. The second design principle is the design should be traceable to the analysis model. That's one of the most important points in the design activity. Every design we do must be traceable back to the requirements. Understand it like this one. If you are designing a screen, or if you are designing a user interface or an output report or an input screen, if somebody asks you why you are designing that screen, then you must be able to answer him that this screen is being designed because this is one of the requirements of the user, and that screen is required to satisfy that requirement. So every design which is done must be traceable back to the requirements. And similarly, every requirement must be traceable back to the user, that which user gave that requirement. Another design principle is the design should not reinvent the wheel. Again, that's very important. As we'll see that a lot of people have done a lot of work on the design of different kind of software. So if a good design is available, we should be using that design instead of doing a design of our own, which might not be a very good design. So if a design is already available, we should be exploring that design, or might be customizing that design to best suit our requirements. There is no need of doing the design of each and everything from the scratch. Another principle is the design should exhibit uniformity. Now, uniformity of the design is again very important. Think that if you are using a software and if you go from one screen to another screen and the layout and the font and the color of the screen totally changes, you'll get confused. Similarly, when you are designing the reports, the user interfaces, you should design them in a uniform way. The font size you select, the font type you select, the coloring scheme, the heading, and the places of different information should be selected very carefully and in a uniform way. Another design principle is the design should be structured to accommodate changes. Again, the software, as we said before, is not a static entity. It changes. Because the design is derived from the analysis and from the user requirements. So if the user requirements change, and of course our design should also change to accommodate those changes. So when you are doing the design, you should keep that thing in mind, how the user requirements can be reflected in the design. Another principle is design is not coding and coding is not design. Most of us basically when they are doing the design, they focus too much on the programming, that how it will be done. So if somebody is an expert in one programming language or in one package, and when he is doing the design, he is always thinking in terms of how that thing will be ultimately implemented in that programming language or in that package. That can not lead you to a better design. Once you are doing the design, you should not be thinking too much about the implementation detail, because design is not coding. Once you have to do the design, and once the design is done, then the coding stage will come. So we should not restrict and limit our design to the coding. The coding is a separate activity, and the design should also be taken as a separate activity. Another design principle is the design should be assessed for quality as it is being created. That requires a continued review of the design. And the design should be reviewed to minimize conceptual errors. We discussed that thing many times, that a good software engineer always tries to minimize the errors early in the development phases. Because if an error or a mistake slips through the next phase, that is very costly to correct. Therefore, while we are doing the design, we should keep reviewing the design, we should keep improving the design, and we should keep removing the errors in the design. Dear students, to do a good design, you should also be aware of some of the basic design concepts and terminology. Having a good understanding of them is essential in design activity. The most important design concepts are the concept of abstraction. So basically we have the data abstraction, the procedure abstraction, and the control abstraction. Another design concept is the refinement, which is the elaboration of details for all the abstractions. Then modularity, which is the compartmentalization of data and functions. And the architecture, which is the overall structure of the software. And the procedures, which are the algorithms that achieve the functions. And the hiding, which is the controlled interfaces. So these are some of the basic design concepts which every software engineer should be aware of while doing the design. We will be doing a lot of discussion about each one of these concepts with many examples to explain that what we really mean by the abstraction, for example, or the refinement or the modularity. In the coming programs, we'll be discussing these points in much more detail. Dear students, in today's program, we defined what is software design. We discussed how various designs can be obtained from various analysis models. We outlined the software design process and emphasized the point that software design process is highly iterative in nature, and a designer must continually improve the design. We also discussed the characteristics of a good design, and we outline some of the design principles. In the end, we introduce some basic design concepts which we will be elaborating and discussing in the coming programs. Till the next program, Allah Hafiz.